Hi everyone, and welcome to today's lesson where we will be proving triangles are congruent. And we'll be doing this through some new theorems and postulates. Let's get started. So up until this point, we've been talking about how if all 6 corresponding pieces are congruent, then you have congruent triangles. But you actually don't need to show all 6 in your proof. If you did, that'd make it forever long. All you really need is 3 pieces. Okay, if you have 3 pieces, then you can say the triangle is congruent because the rest will naturally follow. So here's the question, which 3 pieces? And here's where we get into today's postulates and theorems. First up, we have the SSS postulate, or the side, postulate. In this postulate, if you can show in your proof that all 3 sides of the triangle, of each triangle, are congruent to each other, then you can say the triangles are congruent. And the reason you can say this is because, as we'll learn later, if the sides are congruent, the angles necessarily have to also be congruent, which is where you get the other 3 pieces. All right, next up on our list, we have side angle side postulate, or SAS postulate. Side, angle, side. Now the trick on this one is to pay attention to the order. Okay, notice how the angle is in between the 2 sides. That's very, very important. Now what this one is if you have 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of the other triangle, then the triangles are congruent. Now, a bit of vocab. An included angle is the angle between the 2 sides. It's created by the 2 sides, which is why I pointed out the name. So if you look down here in the picture, notice that angle C, our congruent angle, and angle Z, the other congruent angle, are in between the 2 congruent sides. Okay? Order matters on this one. If this angle is not in here, then it doesn't count. Okay, now briefly let's talk about what does that mean. Okay, let's say we have angle A over here and angle X over here. Now notice how angle A and angle X do not have the 2 congruent sides on either side of them. Okay, you have this blank side. All right, this is why A and X are not included angles. Okay, because you have this blank side on the one side. In order for them to be included angles, they have to be in between your 2 congruent sides. Now our next postulate and our last postulate of the day is the angle side angle postulate. Again, pay attention to the order. The order of the name tells you the order of the information. Angle, side, angle. All right, so last time we had a letter sandwiched in the middle. It ended up being an included piece. So pay attention for that when we write the definition. Now this one states that if 2 angles and the included side, there it is, in one triangle are congruent to 2 angles and the included side of the other triangle, then the triangles are congruent. All right. Now included again means in between the 2 other pieces. So we look at BC and EF. Okay, these 2 sides have the 2 congruent angles on either side of them. And that's very, very important. If it's not in between the 2 angles, then it's not an included side, and you got to do something else. Now, so far we have 3 postulates, and with these 3 postulates, what we can do is we can prove that triangles are congruent to each other without having to do the very, very, very long route of proving all 6 corresponding pieces are congruent. So the way our proofs are going to go is if we can prove any of these 3 pieces of information correct, then we can immediately jump to the triangles are congruent because of these postulates. And once we have those proofs, once we do those, we can prove theorems. Now this is the first theorem, and this is what we're going to prove on the next slide using our original 3 postulates, but I want you to see it first. Okay, this is the angle side theorem. Again, pay attention to the order. Notice how on the last slide, side was in between the two angles. Now the side is not in between the two angles. Order of the name tells you the order of the information on the picture. So if two angles and the non-included side of one triangle are congruent to the two angles and the non-included side of the other triangle, then the two triangles are congruent. Okay, you look down at the picture there. Notice how the congruent sides are off to the side. Okay, they're outside. They don't have, there's nothing on this angle over here. And that's what makes it the AAS theorem. Now this is the theorem, because it's the theorem, we have to prove it. This is the theorem we're going to prove on the next slide. So let's go ahead and get to it. Here we go. We are going to prove this theorem, which means we cannot use this theorem. All right, now for my given information, I'm just going to use the information they tell me in the picture. So angle C is congruent to angle F, and angle B is congruent to angle E, and that AC is congruent to DF. Now, because I can't use the AAS theorem, I have to use one of my postulates. So I'm going to write those down. First off, I have SSS postulate. Then I have SAS postulate. And then I have ASA. All right. Now, looking at the picture and looking at my postulates that I have, the first thing I notice is that I have two angles and a side. So that is starting to look like this one, but the order doesn't match. Okay, the information that I have in my picture does not match the order the name is requiring. However, this is the only name that has two angles, and I have two angles, so I'm going to try to think on those lines. And as I'm looking at this picture, I see that I have two angles of one triangle are congruent to two angles of another triangle. I'll give you a second to see if you can think of the theorem I'm going to use. All right, there was your second. If you were thinking of third angles theorem, you were correct. So, as a reminder, third angles theorem tells us that if two angles of one triangle are congruent to two angles of another triangle, then the third angles of those triangles have to be congruent to each other. They have to be. So that means that angle A is congruent to angle D. All right, so now I look at my picture and I need to use ASA because it's the only postulate I have, and now I have it. I have an angle, a side, and an angle. And over here I have an angle, a side, and an angle. I have the order of the information that I need, so I can jump on in and I can say that triangle ACB is congruent to, pay attention, the names have to match. So triangle DFE. If those names don't match, then you will lose points because you didn't name the triangles correctly and the corresponding pieces don't match up. Now, the reason this is true is because of my postulate. Angle, side, angle postulate. Sign off and you're done. We have now proven the angle, side theorem. So anytime you see the order of information, angle, side, you can now just say it. These two triangles are congruent. All right, let's keep going. Now, as we just talked about, three postulates, one theorem, those are the ones that do work. Now, what order of information doesn't work? There are two. There are two orders of information that do not work. The first one is angle, angle. Okay? If you have all three angles of one triangle are congruent to all three angles of another triangle, you can't prove anything with that. You don't have enough information. Now, if you're confused, think about your phone. All right? If you're looking at a picture on your phone and you were to zoom in on that picture, okay, the angles of the original picture and the angles of the picture where you zoomed in on are still the same. You still have 4 right angles there. However, the sides of those pictures are totally different. The original length of the picture was a lot smaller than when you zoomed in. Same thing if you were to go the other way. If you were to have a big picture and you were to zoom out, all right, and make it smaller, you still have 4 right angles. It's still a rectangle, but your screen, the image is now smaller. Okay, so the sides didn't match up, and that's important because in order for 2 shapes to be congruent, all the angles and all the sides have to be congruent. So angle, angle, angle does not work. Now the other one that doesn't work is the side angle. Okay, and the reason why this one doesn't work is because you cannot anticipate, or you cannot predict, guarantee, whatever word you want to use, the length or the placement of this side. Okay, so say I have those pieces of information. I'm going to blow it up a bit so you can see it. There's one triangle. Here is a congruent angle. Here is a congruent side. Actually, no, wrong side. I want to pick this side. There's a congruent piece. This side right here, I cannot guarantee its length because think a fishing pole. If you're fishing in the water, all right, you have a length of line. The pole is the same, which means that this side is also congruent. You cannot guarantee how far in the water that you throw out that line, okay, because it could fall. You could swing this in, and I'll change color so you can see. You could swing this in and have a picture that looks like this. Okay, my pole hasn't changed, my angle hasn't changed, neither has the length of my line, but it has now swung in so that's fitting closer to me. Now this measure of x, this measure right here of x, and this measure right here of y are most certainly not the same length. And so even though I have 2 congruent sides and a congruent angle, because the angle is non-inclusive, I cannot guarantee the length of that third side because that third side could be really long or it could be really short. Now the trick that I like to use remembering this is no donkeys in math. All right, you are not allowed to have any kind of donkeys in math. And if you don't get the joke, I'll explain it to you next time in class. But you cannot use the information of side angle. That just doesn't work. All right, bit of an apology to make. So, side angle. On the last slide, I just finished saying that there are no donkeys allowed in math. This is true. Except there is only one instance where you are allowed to have a donkey in math, and that is when it is a right donkey or a right triangle. All right, again, if you don't get the pun, I'll explain it to you in class. But when you have a right triangles are special. Therefore, they have kind of their own rules. HL theorem. HL theorem stands for the hypotenuse leg theorem. And it is the only instance of side angle that works. So when you have a right triangle, look and see if you have HL theorem. Now what this one states is that if you have the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and the leg of the other right triangle, then those triangles are congruent. And you can actually prove this a couple ways. Pythagorean theorem is probably the easiest one to just think about and realize it must be true without having to prove it. But HL only works with right triangles. That being said, just because you have a right triangle doesn't mean it's gonna be HL. Okay, you could have side, you could have side, angle, side. You could have any of the other theorems. But if you have a right triangle, always check for the possibility of the HL theorem. All right, now that we have gone over all of our theorems and postulates, let's do a few proofs and practice. So this picture right here, I'm going to draw out my proof, and then we'll walk through it together. So in this information, I have that R is the midpoint of both QS and PT. Pay attention to that, because sometimes the given will say R is the midpoint of both, and sometimes it'll say that R is only the midpoint of one. Okay, do not take it for granted that R is the midpoint of both. You have to be told. But since we're told, there it is. Okay, so I'm going to take that, I'm going to write it in my given. So I know that R is the midpoint of, let's get an F, of QS and PT. And this is given. And that's it. And I'm trying to prove these two triangles are congruent. Interesting. So let's list out what we have. What do we know? Okay, and what I mean by this is list out our postulates and our theorems. So I have side, 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 angle, side, angle, side, angle. Those are my postulates. Here are my theorems. Angle, angle, side, and then HL. Well, right away, as I'm looking at this, I know I don't have right triangles, so that one's out. Bye. I do have two congruent sides. I have side information. So I'm going to scratch off AAS and ASA because those have two angles. And I don't have two angles. I have two sides. So I'm looking at these two. Now, as I'm looking at these two, I'm looking at the picture. I see something. Hopefully you see it too. What I see is this vertical angle pairing. Okay, I have a vertical angle, which means I have a side, an angle, and a side. And that's going to fit this one right here, side, angle, side, because I have that exact order. So I'm going to, for this proof, do the side, angle, side route. Now, there may be times where you have multiple pieces of information. Totally fine. Make sure you find and you say in your proof the exact order of the information you're using. That being said, I'm given a definition, so turning to my proof, let's use it. Because I have midpoints, I know that QR is congruent to RS, and I know that PR is congruent to RT. And I know this because of the definition of midpoints. Next, I'm going to use my vertical angle. So I saw vertical angles, and I'm going to use it. Make sure you name this properly, though. So I have angle QRP is congruent to angle SRT. And what I mean by name properly, vertical angle theorem, is please don't just say angle R. Don't just say angle R, because remember there's 1, 2, 3, 4 angles that have R as a vertex. So you need to name it properly so that I can tell which of the angle R's you're even looking at. Okay. That being said, I'm going to do one last look over my proof. Here's one side. Here's my angle. Here's the other side. All the information that I need is in my proof. And so I'm going to say that these two triangles are congruent because of the side, angle, side postulate. Sign off and you're done. Okay, how'd you do? Are you anticipating the information? All right, if you're not, here are some key ones. Vertical angles. Vertical angles are always going to be something to look for. Shared sides, any kind of shared information, a shared angle, a shared side, that's going to be your reflexive property, and that comes up a lot on these proofs sometimes. And then last but not least, parallel line facts. Okay, you're going to have a lot of parallel lines, particularly alternate interior angles. Okay, so be on the watch for those three things: vertical angles, reflexive pieces, and parallel lines, because those pop up and you can use those to get more information out of your picture. All right, last proof. See what you guys can do. Video's going to pause. When it plays again, you'll see the right answer. And here's the answer. How'd you guys do? So with this proof, you were given two big definition words or vocab words in the given. You were told that you had a midpoint, and you were told that you had perpendicular lines. So as a reminder, when you're given a vocab word, use the vocab word. So I did perpendicular first, and I said that because because the definition of perpendicular lines, I know that these two angles are right angles. And because they're both right angles, that means they are congruent to each other, because all right angles are congruent. Okay, we haven't really used this one a whole lot yet. Some of you might be familiar with it, but you are more than welcome to start using it now. If ever you have two right angles and you've said that they are right angles, you can say that they are congruent, because all right angles are congruent. Next, I did the definition of midpoint to get ME is congruent to EJ. So that's both vocab words used now. And that's how I have my side, one of my sides, and then this angle right here. Then all that's left is to do the reflexive side. Two things here. You do have to say this step. Okay, you have to have that two angles are congruent in order to use the side angle side postulate. Okay, same thing down here. You have to state for the audience that these two pieces are congruent to each other because they are in two separate triangles. Same side, two separate triangles. So you have to clarify that yes, these two things are the same. All right, that's the end of the lesson. Let me know how you did when I see you next, and I'll see you next time. Bye.